Okay, so section 6.1 is our first section of this unit, and this unit is all about polygons. So, and a polygon, just to recap if you didn't know, is a figure that has 3 or more sides, okay? And then all of the sides are straight lines. So there's no like curved lines, like circles are not considered a polygon. And yeah, so that's what it means to be a polygon. So some polygons, if they have a certain number of sides, they have special names. So it has 3 sides. It's of course a triangle. I've never heard the word trigon. It's kind of a cool word. If you want to start calling them trigons, that'd be pretty sweet. A quadrilateral, of course, you've heard that word, is a 4-sided, or tetragon. Yep, start calling them tetragons. I'll be very impressed with you. Pentagons are 5, hexagons have 6 sides, heptagon with a P is a 7-sided, octagon is 8, nonagon is 9, or anagon, I don't know, I've never heard that one, I always have just heard nonagon. Decagon is 10, deca means 10, undecagon or hendecagon is 11-sided. I know these names are crazy. And a dodecagon is 12-sided. So if there's anything like 13 or more, they're just gonna say n-gon. So like if there's a 57-sided polygon, they would call it a 57-gon. Yeah, I know, it's a little crazy. Okay, so whenever we're dealing with these polygons, there's there's 2 theorems we're going to talk about today, and the first one is called the polygon angle sum theorem. So this is the measure of the interior angles. Okay, so to see what the inside angles all add up to be would be n minus 2, here's the formula, times 180. So let me just prove to you that this works. So the one that you probably know, because we've talked about it a million times, is a triangle. So we know a triangle, all the angles equal 180, right? So if I plug it into that formula, which is n minus 2 times 180, where n is the number of sides, you would say 3 minus 2 times 180. And you have to do what's in the parentheses first, that's why it's there. So that would give you 1 times 180, which, yep, that's 180. So it does work. So this works for all of them. This is definitely something I would have memorized if I were you. So here's the first question. What is the sum of the interior angle measures of a heptagon? So if you remember from our chart, a heptagon, it has 7 sides. So we would plug that into our formula. So instead of n, I'm going to put 7. That's where the number of sides goes. Minus 2 times 180. So do the parentheses. So that gives you 5 times 180. And that gives you 900 degrees. So all of the interior angles of a heptagon add up to be 900. Kind of cool. Okay, let's do the same thing. What is the sum of the interior angle measures of a 17-gon? So that has 17 sides. So again, you're just going to plug it into our lovely formula. 17 minus 2 times 180. So you subtract. So that would be 15 times 180. Then whenever you put that in your calculator, you get 2,700 degrees. And again, that's what all of them add up to be. All right, so now the sum of the interior angle measures of a polygon is 1,980. How can you find the number of sides on a polygon? So now we're trying to find the n, the number of sides. So we know whenever you work the problem out, it's going to equal 1,980. And then I'm just going to write my formula, which was n minus 2 times 180. Okay. So what do you think we would do first in order to get the variable by itself? Well, first thing, we can't start adding 2, okay, because it's in the parentheses. The first step you have to do on these problems is get rid of the stuff next to the parentheses. So it's times 180, so I'm going to do the opposite and divide by 180. So those cancel, and you're left with n minus 2 in parentheses equals 11. Okay, so now, since there is nothing left on the left except for the set of parentheses, the parentheses aren't doing anything. They're not separating that from anything, so it is perfectly fine, and actually you're going to see me do this a lot, is I am going to drop those parentheses because they're not doing anything. Right now we just have a one-step equation, so we're going to add 2 to both sides. So that would mean the number of sides for this would be 13. And that is our answer. If we wanted to check it, we totally could. We would plug it into our formula. So this is how you could check these problems really easily. It wouldn't take that long. You would do 13 minus 2 times 180. And it should equal 1,980 whenever we solve it. Let's see, do your parentheses, so that gives you 11 times 180. 11 times 180, put that in your calculator. Sure enough, you get 1,980, which is what we wanted it to equal, so check, this works. Okay, let's talk about some vocabulary. So an equilateral polygon. We've talked about equilateral triangles, and that's when all of the sides are the same, right? So the same goes with an equilateral polygon. So that means polygon that has all the sides are congruent, okay? So it could look something like that. It could be a square. I mean, there's a lot of them that it could be. Okay, an equiangular polygon, so angular is the key word, and equiangular is how you say it, so it's equal angles pretty much, is when a polygon that has all angles are congruent. Okay, and now here's the last one. Whenever you see regular, and you're going to see this a lot, that means equal sides and angles. Okay, so the sides are equal to each other, they're all the same length, and then the angles are all equivalent too. Okay, so something you definitely want to memorize what that means is the word regular. No, angles are the same, sides are the same, because it will come up again. All right, so here's another way to do it. So, or another theorem to find one interior angle in a regular, has to be regular, polygon. You have this formula: n minus 2 times 180 divided by n. And this really makes sense because the top line, this is the total interior angles, so that's all of them add up, right? That's the same formula we've been doing. And then you divide it by the number of sides, which if it has that many sides, it also has that many angles. Okay, so this is when you're just trying to find one angle, and it only works for a regular polygon. So know that, must be regular. If it's not regular, this formula does not work. Okay, so here's our problem. Find the measure of each interior angle in a regular nonagon. So how many sides does a nonagon have? So nonagon is 9. All right, so how we're going to do this is you're going to set up your formula, which was over here. And it is regular, so we can use this formula. It says regular. So it's going to be 9 minus 2 times 180, all divided by n, which is your number of sides, so 9. All right, go ahead. We have to do what's in the parentheses first, always and forever. So do this part. So that gives you 7 times 180 over 9. And now the next step you have to do is solve the top before you divide it by 9. So solve the top. 7 times 180 is 1,260 divided by 9. And now we're finally ready to divide by 9, so that would give me 140 degrees. Okay, so that is your answer. So each angle, the interior, so the inside angles of a nonagon are 140 degrees. Pretty cool. All right. So now, what is the measure of angle Y in pentagon today? Look how they spelled T-O-D-A-Y. They're getting fancy. So I'm just going to go ahead and stick with Y and call that angle Y. So that's a certain amount of degrees that we're trying to figure out. So they tell us what 3 of the angles, and then they give us the right angle symbol, so we know that's 90. So first thing, whenever you're doing that, you have a pentagon, so it has 5 sides, which you can count 1, 2, 3, 4, 5, yep. So first thing you need to do is find the total interior angles. So what do they add up to be? All of them. Well, we have that formula from the first page of the notes. So it's n minus 2 times 180. So n is 5. So 5 minus 2 times 180. Then you would solve that. That would give you 3 times 180. All right, and so the total is going to equal 540. All right, now we're ready to set up our equation. So we have 540 equals, and then we're just going to put every single one in there. So the first one I'm going to put is Y. I have a 90 degree, 120, 150, and 110. I got a little out of room there, but that's okay. So I added up all 5 angles. Double check that you have 5. 1, 2, 3, 4, 5. Yep, I do. Okay, now we just get to do some good old algebra and solve it. So I'm going to add up all of these. To save time, I already did it. And you get 470 equals 540. Next step would be to, of course, subtract both sides by 470. And you get Y equals 70. So Y equals 70 degrees. Does that seem realistic? Yeah, right? I didn't get it like a weird negative number. That wouldn't have worked. I didn't get like 3,000 as an answer. That looks like it could be a 70-degree angle. Absolutely. It's an acute angle. Yep, for sure. Okay, let's do another one. What is the measure of angle G in quadrilateral EFGH? So I'm going to do what I did last time and call this angle G. So that's G degrees. That's what we're trying to figure out. First, we need to figure out the total amount of angle or degrees inside of a quadrilateral. So you may have already know the answer to this, but I'm just going to work it out just in case you don't. So the total, you would do, the total number of sides is 4. So 4 minus 2 times 180. Would give me 2 times 180. So the total inside angles, interior angles are going to be 360 degrees. Sweet, we got that. Let's keep moving. So let's add them all up, and they're going to equal 360. So G plus 120 plus 85 plus 53 is going to equal the total, which is 360. All right, combine your like terms, so add all of those together. And I believe you get 258. Bring everything else down. Go ahead and subtract by 258 to both sides. So G equals 102 degrees. Okay, and that seems realistic for a G. That looks like a 102-degree angle. Yeah. Okay, so we're almost done with this, don't worry. So now let's talk about exterior angles. And remember, the word exterior means outside. So whenever you're drawing these polygons, they have, of course, the inside angles, which are right here, right? But then you can also extend a side. Okay, let me erase those really fast. So you can extend each of the sides in one direction, like this, and they make these exterior angles. So these are the exterior. Okay, so if you notice how they find those exterior is they make a straight line, so they're always supplementary. They add to be 180. 80 plus 100 is 180. 30 plus 150, 180. 50 plus 130, 180. Okay, so they're always going to make a supplementary angle, or they make supplementary angles with the interior angle. Okay, so what's really cool about this is that there's this theorem, but I kind of like let's just write it out. So the exterior angles always, this is where it's nice, always add to be 360 degrees. So exterior angles always add up to be 360 degrees. It's pretty sweet because if you think about it, if you were to piece them together, so I'm not going to draw it because it would be really bad. Sometimes you'll see textbooks draw it. But if you were to put 80 plus all these angles together, the exterior ones, they would make a perfect circle. It's kind of neat. So, and a circle is 360 degrees. Okay, so just remember, exteriors always add up to be 360. So that's pretty much what this theorem says. Okay, 2 more questions. What is the measure of angle 1, so this is an exterior angle, in the regular octagon? What does it mean for an octagon to be, or this to be regular? Well, it means all the sides are the same, and it also means, so it has the same sides and angles, right? So now it's pretty cool. We know all the angles are the same, so every single one of those exterior angles must be also the same. So we know their total is going to be 360. And so now you just take 360, and since they're all the same, you're going to divide it by the number of exterior angles there are, which is 8. And you divide that out, and you get 45 degrees. So each one of these is 45. Okay? Kind of cool. I could go all the way around, but I'm trying to save time. Last question. What is the measure of an exterior angle of a regular nonagon? So they don't give you a picture, which is no big deal. We're still going to crush it. Nonagon. What is nonagon? That's 9 sides. Okay? So if there's 9 sides and it's regular, good. You can't do this if it's not regular, because in order for them to be regular, they're all the same. So if they're a regular polygon, that means they're all the same. So you're going to take 360 again and divide it by the number of sides, which is 9. And that gives you 40 degrees. And that is your answer. That is it for polygon angle sum theorems. Hope you enjoyed it. Have a great rest of your day.